Hey everyone, I'm Hiro. Welcome back to the CISA exam prep series. In this video, we are covering Section 6, Sampling and Data Collection. Here's the situation. Imagine you are auditing a bank, and they have 100 million transactions to review. You have 3 weeks. That's the problem side. Checking every single record, it would take years. The cost would be enormous. It's simply not possible. Check every record? Obviously, no. Takes years, costs a fortune, right? Simply not possible. So what do you do instead? You use sampling. You pick a representative subset of records. Test those and draw conclusions about the whole population. You test a subset of records. You draw conclusions about the whole. It's efficient and mathematically sound. Think of it like tasting soup. You don't drink the entire pot. You take 1 spoonful and you judge the flavor from that. 2 approaches to sampling. Now, there are 2 broad approaches to sampling, and the key difference is how you make your decisions. The first is statistical sampling. This uses mathematical models. The results are objective and repeatable. And crucially, sampling risk can be expressed as a number. You can say, there is a 95% confidence level that this population has fewer than 3% errors. That's a concrete, defensible statement. Objective, quantifiable results. You can show your math. Sampling risk can be measured numerically. This is the key advantage. The second is non-statistical sampling, also called judgmental sampling. This uses the auditor's experience and professional judgment. Instead of randomly selecting records, you deliberately target areas that look suspicious. Deliberately targets suspicious areas. The auditor decides where to look, also called judgmental sampling. Remember both names. Both are valid tools. The choice depends on your audit objective. When you need to defend your results with hard numbers, go statistical. When you are following a hunch based on experience, non-statistical works. Match the test to the sampling method. Now, here's an important pairing you need to know for the exam. The type of test you are running tells you which sampling method to use. Compliance testing. Did they follow the rules? Pairs with attribute sampling. Attribute sampling checks yes or no. Was the approval stamp present? Was the password change logged? It's binary. Either the rule was followed or it wasn't. Substantive testing. Is the data accurate? Pairs with variable sampling. Variable sampling checks amounts and quantities. What's the total inventory value? How large is the discrepancy between the invoice and the payment? You're measuring numbers, not just checking a checkbox. The bottom line, the test type tells you which sampling method to use. Compliance goes with attribute. Substantive goes with variable. Lock that pairing in. 3 specialized sampling techniques. Beyond attribute and variable, there are 3 specialized techniques, and each one fits a specific situation. First, stop-and-go sampling. This is for very clean environments, places where you expect almost no errors. You start with a small sample, maybe 20 items. If all 20 are fine, you stop there. Audit complete. If even one error shows up, you expand the sample and keep going. The goal is maximum efficiency when you are not expecting to find anything. Second, discovery sampling. This one is for fraud investigations. The premise is, if even one fraudulent transaction exists, that's serious, and there are probably more. So, the moment you find one instance, you don't just note it down. You switch to a full examination of all records. One is enough to trigger action. Third, stratified sampling. This is used when your data varies widely in value. You divide the population into groups, called strata, and apply different levels of testing to each group. High risk, high value items. Examine all of them. Low risk, low value items. A small sample is enough. Focus your effort where the risk actually is. What determines sample size? So, how do you decide how many items to sample? It's not just a gut feeling. There are specific factors that drive the number up or down. Two factors increase your sample size, meaning they require more rigorous auditing. First, a higher confidence level. If you need 99% assurance instead of 90%, you need more data to back that up. Think of clinical trials for a new drug, because lives are at stake. They test thousands of participants. Second, a higher expected deviation rate. If a department has a history of errors, you need to dig deeper. You wouldn't skim through a report from someone who's known for making mistakes. One factor decreases your sample size. A higher tolerable deviation rate. If you are willing to accept up to 5% errors, that's fine. You don't need as many samples. But be careful. Setting this too high means you are accepting more risk. Quick summary: confidence level up, or expected errors up. Bigger sample. More risk tolerance. Smaller sample. Sampling risk. The courtroom test. Now, here's the hardest concept in this section. Sampling risk. Because you are only testing a subset, there's always a chance your sample gives you a misleading picture. There are two ways this can go wrong. The first, and most dangerous, is incorrect acceptance. You conclude no problem, but in reality, the population was full of errors. In courtroom terms, a guilty person was acquitted. Your sample happened to look clean. You proved the good records by chance. The actual population, full of problems. This is the most dangerous outcome for an auditor. Errors go undetected. Real damage happens and you missed it. The second type is incorrect rejection. Your sample looked problematic, so you raised a red flag. But the full population was actually fine. You just happened to pull the bad records. An innocent person was suspected. Your sample looked problematic, but reality, everything was fine. It wastes time, yes, but further investigation will eventually show they are innocent. The final conclusion ends up being correct, so it's more tolerable than incorrect acceptance. The bottom line: incorrect acceptance is the number one risk to avoid. Missing real errors is far more dangerous than over-investigating something that turns out to be fine. Let's wrap up section 6. Sampling lets you test a subset and draw conclusions about the whole. It's essential when dealing with large datasets, which is basically every real audit. Attribute sampling goes with compliance testing, yes/no checks. Variable sampling goes with substantive testing, amounts and quantities. For fraud investigations, use discovery sampling. The moment you find one instance, shift to a full examination. Sample size is driven by confidence level and expected error rate. Higher on either one means a bigger sample, and the risk to avoid at all costs. Innocent acceptance, concluding there's no problem when there actually is one. Alright, that's it for section 6. Thanks for watching, and I'll catch you in the next one.